Start with a different method to solve, again, systems of equations. So yesterday we looked at graphing. Today we're going to do what's called the substitution method. So first let me give you two sample equations, and then I'll show you what you need to do. X plus y equals 15, and 4x plus 3y equals 38. The first step is going to be to get one variable by itself in one of the equations. Notice I don't say which variable. You can choose whichever one you like. We're going to get one variable by itself in one of the equations. So what you need to do is look at it and decide where would that be easiest to work. For example, this second one, the x and the y are going to be harder to get by themselves because first I move one term over and then I have to divide everything by that coefficient, by that number that's being multiplied. Whereas in this first one, it's going to be pretty simple to get x or y by itself. All I have to do is subtract the other one and move it to the other side. So first take a look and decide which one would be easier to work with. I'm going to suggest in this case, this one is easier to work with. So let's go ahead and do step one down here. And let's decide. It doesn't matter which one. X and y both look equally easy to get by themselves. CJ, which one do you want to get by itself, x or y?
Y.
Okay, CJ says get y by itself. To do that, we would subtract x from both sides, right? So I get y equals 15 minus x, or you could do negative x plus 15. We're not graphing though, so we don't need slope-intercept form. So there's step one. Step two, this is called the substitution method. So first I'm going to kind of write down what the steps are, and then I'll show you what it means, because it may not be clear right away. Substitute, hence the name, substitution method. Substitute the value for the variable into the other equation, and I'll explain this. Now I put value in quotation marks because we don't really have a number. Usually when I say the value, we say a number. What's the value of this bill? Oh, $10. What's the value of X? 5, or whatever it might be. So here's what I mean. First of all, I put it in quotation marks because here's the variable I got by itself. I don't know what y equals. I can't say y equals 2, y equals 5. I don't know yet. I know this is what y equals, right? Everybody see what I'm saying there? I don't know the value of y, but I know that y equals 15 minus x. So this is the value that I'm talking about. It's not just a plain number, hence the quotation marks. Now, I'm going to substitute this for the variable in the other equation. Here's what I mean by that. Take a look at our second equation. I have 4x plus 3y equals 38. The way that is, there's no way to solve it, because I don't know what x is and I don't know what y is. Oh wait, I kind of know what y is. I know y equals 15 minus x. Y, whatever that value is equal to this value. So what I'm going to do is I'm going to take this value that I highlighted in yellow, this value, and I'm going to substitute it for the y in the other equation. If these two sides of the equation are equal, then I should be able to substitute the 15 minus x in place of the y. So here's what happens when I do that. I still have 4x plus 3 times my value of y. Well, I could either write y and then I can't solve it, or I can write this amount that I know y equals. So again, we get one variable by itself. We take this value that that variable is equal to, and we take that amount and plug it in for that variable that's all by itself in the second equation. Now, let's simplify. We need to do the distributive property. 3 times 15, 45. 3 times negative x, negative 3x. Look at what happened. I only have x's now. I can solve for x. There's no more y in this because I took out the y and I plugged in what I know is equal to y in its place. So first let's combine like terms on the left side. 4x minus 3x makes 1x. So now I'll say solve for both variables is the last step. So we're solving now. We're solving for x. My last step, I subtract 45, and I get x equals -7. I'm almost done. I know x is -7. How can I find what y equals? Carissa?
Substitute the 7 for the x.
Good, we're going to substitute again. I'm going to take the value, and now you can choose either one to plug this value of x in to find y. Go with the easy one. This first equation is going to be way easier. Instead of x, I put -7 plus y equals 15. I take the value of the, oops, let me scoot it up. It was originally this, the simpler one. I take the answer that I know. I now know a value for x, and I plug it in for x, and now I can solve for y. This is a -7, the opposite of that, plus or +7, and I get y equals 22. Done. Now, think about yesterday. If the lines crossed, you got an x-y pair. This is the same thing as this. We just got it in a different form, and we're not going to graph it, so we don't need to go to 22 on the y-axis. Right? This is an x and a y, just like we got yesterday with a coordinate pair. So if you get an answer where you get an x and a y, that means these lines, if we graph them, would cross at this point. This is the one pair that will work. Let's do one more. And then I'll show you what infinite solutions and no solutions would look like in this method, because you might get some of those again. So, one more example. Any questions on what we did there before I pull it down? Hopefully by doing one more example, that might get to any questions that you do have. Next example, 2x minus 3y equals 4, and x plus 4y equals -9. So we need to pick one variable in one equation to get by itself. Which one looks like it would be the easiest to get all by itself? Daniel.
X plus 4y minus equals -9.
Good, and to get the x by itself, right? What you want to do is if there's one that doesn't have a coefficient in front, go for that one. Trust me, it will be easier. So let's get this x by itself. All we have to do for that is subtract 4y on both sides, and my new equation here, x equals -9 minus 4y, or -4y minus 9. The order doesn't matter as long as the signs stay the same. So now I have a value for x. I don't really know what x equals yet, but I have something that it is equal to. So I'm going to take this amount that x is equal to, and now I'm going to take it and put it in place of the x. If this value is equal to x, then I'm going to get rid of the x. 2 times x. Instead of x, I substitute the amount that is equal to x. Okay, so instead of this x here, I now have it right here. And now we're practicing. Remember, by the way, when we get to the final exam, we're going to be going over things like the distributive property. At the beginning of the year, we did those as separate lessons. Now, notice we're just doing it in the midst of all these other harder things. So I guarantee you when we start looking back at chapters 1, 2, 3, you're going to be like, oh my gosh, this is so easy. How did I not get A's on everything we did? Because we've been using a lot of those skills throughout this year, like the distributive property. 2 times -9, -18. 2 times -4y, again a negative, -8y. And now combining like terms and watching for our signs, -8y minus 3y, we could add the opposite. That's going to make -11y. And I still have the plain -18. That doesn't have a variable, so it's not a like term. I'm going to start working to get the y by itself. I'm going to start by leaving the y alone, And I'm gonna go to the negative 18 and do its opposite, which is positive 18. I get negative 11y equals 22. When I divide both sides by negative 11, positive divided by a negative makes a negative. Don't forget your signs. I'm halfway, closer, more than halfway done. I have half my answer. Y equals negative 2. Now, if we look back, we can plug that value in for either equation. I'm going to suggest you go with the easier one again. I think the second one is easier. The second one was originally x plus 4y equals negative 9. I'm just rewriting it because you can't see it on the screen here. I'm going to take this value and just plug it in for the y. Substitute. X plus 4 instead of times y, I now know y is negative 2 equals negative 9. 4 times negative 2 is negative 8. You can either write that as plus a negative 8 or just minus 8. Now I do the opposite. I add 8 to both sides. Negative 9 plus 8, negative 1. You can leave your answers like this, just boxed, but always, I just want you to remember, this is what we would get if we did it as a coordinate point, and that means these two lines would cross at this point, and this is the only solution, the only pair of x and y values that would work in both equations. Make sense? Okay, good. Let me just show you what it would look like. We're not even going to solve anything. Let me show you what it would look like when you get a no solution. You're not going to be seeing the graph. If you do all this work and something happens where the variables all drop out and you get something that looks like this. 3 equals 2. What? That's not true. The variables have all dropped out. There's no more variables. I could get x equals 2, but 3 equals 2. That doesn't make any sense. 3 does not equal 2. If you get nothing but numbers and they're not equal, that means no solution. Infinite solutions look similar in that the variables will all drop out, meaning that when you move things, they'll all cancel out, except, bless you, you will get a true statement, 3 equals 3. I don't know what x and y is. Oh, there's infinite solutions. It doesn't mean anything is a solution, but it means there's an infinite amount. If we graphed them, the lines would land on top of each other and share all their points. So this is what that would look like in these problems. Okay? That's it. Be careful with your positives and negatives. Be careful with combining like terms.